vacation. I'm on vacation, and then when I come back, I'll probably
You're on vacation?
go and not crash it.
Nice.
I think we can start with an introduction. Then from there we go into other questions, and then I walk through the firmware so that everyone knows how to use the firmware properly.
Yeah. Also, I had a suggestion. Just wondering, like in the future, were you planning on walking through how your filtering logic works? Because the file was kind of complicated a little bit.
Yeah. I will do that today. Maybe just an overview of the firmware, and then other sections. Then we can say, okay, today is for EKF, and we'll go to the EKF and see what's happening there. Yeah.
Okay, sounds good.
Yeah.
That's cool.
So that's the plan. Okay. Okay. So let me start with the introduction. Okay. I'm Henry, as most of you know. Okay. And I created the HGO build so that engineers and developers and makers can, come together and have a deeper understanding of drones and robotics. And so, on my experience, I worked in the robotics industry. There was a startup in Munich where I worked, and then currently I work in an OEM where we manufacture medical instruments. Okay, and for my master's, I did my master's in mechatronics, and my thesis mainly on drone technology. So most of what I know is from what I did on my master's thesis. Yeah, and we have Jasper here. I've known Jasper for quite a while, and he's also into robotics and embedded systems. And he designed the PCBA, which we are using now, or at least I'm going to use it for the version 2 of this drone projects. Okay. So Jasper, would you like to introduce yourself and say a bit more? Yeah.
Yeah. So as Henry has said, we have known each other for some time now. I think 6 years. 7 years. It'll be 7 years this year. So yeah, I was at the same university as him when he was doing his masters, and so when he started this course, I already was in touch with him, and also already had my frame and other components ready. I already had a desire to do such a project, but I did not have the knowledge, I would say. And so when he introduced this course, it was easy to latch on and quickly come to at least what he's demonstrated as a slightly working version. So he was a good site. I had already everything and saw him introduce the course. It was quick to jump on, and yeah, here we are. So I am right now for work working in the semiconductor industry as an embedded software developer for RF generators for the plasma chambers and the also RF matching networks. So the power that we have in the production of semiconductors. And this company is in US, Germany, Switzerland, and China. This is how our offices are structured. And so on the side, I'm here building drones. Yeah.
That's very cool. Yeah, so I'm Hamza. I graduated last year from Oregon State University in computer science. And then I did a few internships during my undergrad in software development mainly, like building web apps and .NET, that sort of thing. And then after I graduated, I got an internship at Daimler. And so I started working there in active safety for 6 months for ADAS development. And then after that, I got hired on full time. And now I'm working as an embedded software engineer on some new electric truck programs that we have going on. And so I found out about this course just because like I was interested in getting more experience with hardware so I can like, benefit my career and that sort of thing. And I found your course because I was interested in making a drone. So that's just how it happened.
So
Yeah.
good timing, yeah.
Yeah, just random. I was just like browsing because I really liked the STM32. I was doing some projects related with it, learning, and then I liked the platform, so it was cool to see your drone project specifically with STM.
Okay. And you've come a long way from computer science, yeah? So
What was that?
you've come a long way from computer science. So
Yeah, I mean,
yeah.
I'm interested in computer science. I'm interested in this. I want to learn more about embedded, so that way I can do more projects like in edge AI.
Okay.
That's what. So like autonomous vehicles. That's what I'm interested in a lot.
I think that's where everyone is going into right now.
Yeah.
That's interesting. I don't know. Govid, can you give us an intro? Oh, okay. I think it's outdoors right now, so maybe he can speak. Okay. All right. Okay. So how do we start? Any questions in particular before we go into the firmware or the build? Yeah.
Not at the moment right now.
Did you manage
not
to
at the-
do your calibration for the ESC?
I have not yet. I got sucked into trying to set up that telemetry viewer. I haven't done it yet. It's just you uncomment a line of code, right, and then run it.
Yeah. I can. I don't know if you've seen it already, but I can show you quickly how to do this.
I think it was in main.c, right?
Yes. Okay.
Okay. Yeah.
So we have here main.c, and then if you go here, ESC calibrate, then you just run this code instead of this one, and then if we go in, we can see. Okay. Yeah. So you just run the code, and there's a point where you need to power it on. Yeah. I think.
Yeah.
Let's see now. Connect to power. Yeah. So at this point, so
Oh,
there's an
wait. I can't see the line of code because your webcam is straight out, like right on top of it.
Okay. Then I can just.
If you just like scroll down a little, okay, there it is.
All right. So in this section of the code, we're just started. Let me start from here. Here we are setting up the timers. Yeah. And then here we say, okay, we want to have the highest PWM value here. Then we wait a bit, and then we turn on the LED. So this LED tells you different stages of the calibration, right? So when the LED is turned on, then you can now connect your battery. Yeah. So when you connect your battery, you wait a bit, then the ESC gets this 400. That's the highest PWM value, and then you wait a bit more, and then the firmware changes it to the minimum. So now it also gets the ESC gets the minimum value. So now it knows the maximum and the minimum PWM stick values, and does it. Then wait a bit, turn off the LED, and you are good. Okay. Yeah. So just this, and then you have calibrated your ESC so that they all respond to PWM signals the same way. Okay. All right. Okay. So go back to this. So I don't know if anyone has gone through the firmware a bit before I do a run through.
Yeah, I went through it a bit. I just the hardest part was the IEKF.
Yeah.
Wow.
Yeah. It's indeed the hardest part, and
Yeah.
maybe the most important part actually, because with the extended command filter, we can get a reliable estimate of our orientation or attitude. Yeah. And actually, this is coming from an algorithm I got here. So like 5 years ago or so. Yeah, so it's coming from here. And this is a very nice paper I saw during my master's thesis, and that lined everything. First time I heard about quaternions 5 or 6 years ago. And this, so this, the EKF is just an implementation of this algorithm we have here. Right? Okay, so it's a bit involved, you know. So because it's also it also has to do with quaternions, yeah. And we're using quaternions here instead of the normal rotation matrices to avoid things like in gimbal log, yeah. But maybe we can start. Should we start top down, like okay, start from the controller and then see where we go, or we start from bottom, like we start from the IMU and then see where we go from there? Which
maybe it would be easiest if you go through the architecture of like the code, how it's split up into the files.
I think you had this diagram you shared on LinkedIn through the architecture.
oh, I have it here.
Yeah, that would be good. Yeah, that way.
Something similar to that. If I don't know if you can reach your LinkedIn.
All right. So I think yeah, I'm not logged in. Yeah. Okay. So this is the architecture.
Yeah.
So maybe after this, then we can go a bit look at the code or the file structure. Okay. Okay. So this is what we have, layered architecture, and so initially when I did when I started this, because after my master's thesis, then after like 2 years, I went back to it. I did the IO from scratch. I did the entire like how to access every register. Yeah. So that's why I have the register IO here. But now in this, if you notice, I use a how to, because how already implements the like, for example, you want to access a GPIO register. Yeah, I had to code that myself. But now I use the how, yeah, for this. So in this here we just have the input output registers for let's say GPIO special functions and things like that. And then here we have what I would call peripherals, like your I2C.
So
Yeah.
it's possible to shrink your webcam slightly,
Okay. Maybe
and then, or maybe not in a permanent way, just so I can move it and then bring it back later. Yeah.
But this, yeah.
Yeah. That's okay.
Okay.
Thanks.
All right. So, okay. Yep. So in this layer, we have the I2C. This is where we call the I2C on the IMU, because the sensor that uses the I2C is just the IMU for this project, yeah. And so we configure the registers of the IMU to the I2C. In this layer as well, I have the radio signals coming from the the fly sky, yeah. And then we have the UARTs, so the UARTs and DMA kind of together. Then we have the timers for the motors, and then we have the status monitor. So the status monitor is this, basically the LED. Yeah, you can see it here. So, yeah, blinking. Yeah. So we have something like for now, I think we just have powered on, then armed and disarmed. Yeah. For the status monitor, then you can always add some other things you want to monitor there. Okay. And then we have the sensor layer, which builds upon this this layer. Okay, so this I2C, the I2C is kind of connected to the IMU, and then so this sensor.c is like the higher level file that so this is where we do the processing. We call every IMU we call the IMU read. So read the register we call the function that gets the IMU data actually, because the region of the register is done already here in the IMU.C. And then if we go one level higher, we have now the EKF and then a few other applications.
So sensor.c is normalizing the IMU driver, the values that come from the driver.
Well, so sensor.c is just calling the it's calling the functions that read the data registers or the registers to get the data. So what was the question again? I've forgotten.
Yeah, so I was just curious. Yeah, so it's calling the.
I can show you that. Let's go to sensor.c. Okay, so here we have IMU.c and sensor.c. And if we go here, let's see. So this is sensor.c. So
Okay.
right now we have just one sensor, IMU. So think of when we have, like, say, a position sensor or ultrasonic sensor, or maybe we want to check the level of the battery. You do everything here. You should do everything here. Yeah.
Okay.
But for now, we're just calling the IMU data. So previously, I had a function to check the battery level, but I removed it for the cost so that it's just easy. So the next function would be, okay, now I want to call the function to just get the get how low my battery is. Yeah. So this is done in the sensor. Let's see. Yeah.
Yeah. Okay, makes sense. So it's for the future.
Yeah. So that's what's happening here. Okay.
Okay.
And, wait, where I go now? Oh yeah. So from here we go into the filters. Yeah. So this filter.c make use of the data coming from the sensor, which is data coming from the sensor. And then after the filtering with the EKF, we have now a good estimation of where we are or where the drone is. Yeah, right. And then this data is very important for the controller. So when we have the data, the angles and the estimations from the EKF, we cannot compare them with the set points from the pilot. So we have the set point here, and we have the PID. So the PID takes this data coming from the filter and then the set point, and then we say, okay, should we make a correction, and how much correction should we make? Okay. And then send it to the actuators, in this case the motors, right? And here we have the higher level where everything starts. So we have here the task scheduler and things like this, and then here is the telemetry as well. So this is just a brief summary of what's going on.
Yeah.
Maybe we can have a look at the folders, or if there are any questions here, we can maybe answer them before we go to the folders.
Yeah. So, like, what's the history of this repo? Did you code this from scratch?
For my masters,
Yeah.
it's coming from my masters, yeah. So
Oh, this is actually from your. Okay, I think I missed that part.
Yeah, most of it from my masters. Then, as time goes on, you kind of refactor. I've been working on this for like 5 years since then.
Oh wow. Okay.
So refactor,
Awesome.
refactor until it comes to this, yeah. So where do we go from here? So where is it? So this is the repo, and this is HUO builds. So this is a brand new repo that I just made for the course, yeah. But if you see, I also have here my own repo, and I have only these projects public. Those are some of the projects I made. But my actual I have different variations. I have previously tried to do this like 2 years ago, but my idea then was just to write on Medium about drones. That was my idea, and I made this project. This was like 2023, but I didn't go further with it.
Yeah.
Then I had, so yeah, this was another one from 2021. Yeah, so
Mhm.
just keep it iterating until now. We have this is the current version I had before
Yeah.
I moved it to the HGO BIOS, because I just want to have them separate. Yeah.
Nice.
So that's why you see, okay, the history is just, okay, a brand new history. Yeah. So yeah. So just a separation of concerns. Yeah. So okay, this is just when I come to my GitHub, I just know that HGO BIOS is for anything the drone cause. Then I leave my personal GitHub separate. So that's it.
Sounds good.
Yeah. Okay, then we go here.
Did you already calibrate your ESC, Jasper?
Yes, I already did that.
Okay.
I think when I faced this IMU problem, the first thing was suspecting the ESC calibration. So that's one thing I first tackled until he came in to help me do the IMU calibration. Yeah.
I've seen what this IMU calibration can do.
Yeah.
Because mine is definitely like that. I mean, I didn't calibrate my IMU yet. I didn't get a chance yesterday. I was busy, but yeah, like some of my motors turn on, some don't.
Yeah,
Okay,
that's the exact problem that I faced.
then you need to calibrate first the ESC, and then we talk about the IMU calibration. Yeah. Okay.
And I think my experience was that I even had a little bit of frustration towards Henry because I didn't know that such small offsets could render my drone. I thought, I almost swapped motors, like moving them around on the frame, and not knowing that it's actually a software change like that. And I thought, why didn't he just give it a lot of emphasis in his README that calibration is just messes up everything?
But calibration is like number 1 and 2, 3 on the README.
I wish they were bold and red.
How much more do you need?
Oh yeah, but yeah, it was really something that rendered 2 motors actually.
Yeah, so like the first thing is the roll and pitch, calibration.
Yeah.
1 and 4 is calibration. Very important. Unless nothing works, because if you think about it, the drone is just like the drone wants to be leveled. It wants to be at a level surface, or the level itself. So the most important thing is, am I exactly at 0 when I should be? Yeah. So if you get that wrong, then nothing matters again. Yeah. So a little deviation by 1 degree or 2 degrees can actually put you in the wrong direction. Yeah, and mess everything up. Okay. Yeah. So we can go ahead. Yeah. So for this for the firmware, we have different folders. Yeah.
Yeah.
We have the control folder. We have the filter, peripheral. This is the app. We have the sensor and the telemetry. Okay. And so this app is where the program starts from, right? And if we go here, perhaps we should start from the control. What do you think is better, top down or bottom up?
No, I mean, I prefer top down.
Top down.
Okay, let's start from the control. All right. Okay. So this is the main. This is the main .c file where we have the control, and we start here. So maybe a little bit. Let me show you guys a little bit of the bottom before we come to the top.
All right.
Maybe makes
No
a
problem.
bit of sense. Yeah. So that. Okay. So here, this is where we do the initialization of things, of the hardware. And then here we create we create an instance of the sensor, and here we create one for this for the filter, and for the controller, we not only create an instance, we also create a task for it. So here we have a task. This is a task. That's why we have this launch thread or something. So using the RTOS, and this is a task. So we have in this project we have three tasks. We have the control task, the monitor task, and the telemetry task. Yeah. So this and they have different priorities. Yeah. Okay. So the control task kind of manages this filter and sensor. So the controller itself calls the filter, and the filter calls the sensor. Something like this. Yeah. But the status monitor is a standalone task. The telemetry is a standalone task. Okay. So let's look at this.
So, sorry, you said total you have 3 tasks.
Where is it again? Yeah. Okay. Yeah. So these are the 3 tasks. Yeah.
No, okay.
Okay. So maybe I just briefly look at these 2 tasks before we go to the control, because the control task is the main thing here. So for the monitor task, we're not doing much here, and it has the lowest priority 1. I think for RTOS, the way it is set up here, the higher the number, the higher the priority. So this is priority 1, and the lowest here. And I use a tick time of 20, so it's doing 50 hertz for this task. So this task, I'm just blinking the LED in different patterns depending on the state of the controller, basically. Yeah. So when it's armed, we have this, and when it's unarmed, we have it. When it's unarmed, we have it toggling. Yeah, we toggle it. Then when it is armed, we have it on. Yeah. So basically, this is what we do here. It's simple. Yeah. So then the other tasks we have, I mean, we can go in depth later on, but for now, let's just have an overview. Okay. Then for the telemetry, this is what we have here. Telemetry just all the data we have from different section of the code. We want to give the user the capability of printing them out and debugging them to see what we have. Yeah. So the user can decide on what data to give out. Yeah. And if we see here, we have it. We have this type we created here, telemetry type, and it has the sensor and the filter and the control types. So it can call this. So it can actually, so that it knows what a control type means and all that. Yeah. So this is a call. This is a call to the data for each one. So this is where I call the data for each one. Yeah. So for the controller, I call the data structure and everything, and we just assign it here to this. Yeah. The telemetry control variable control, basically. So so if we go here, for example, so here's what I'm returning, and if you look here, it's just returning an object, or it's not the data from this particular instance we have created, which is self. So what we're trying to do here, we're trying to mimic the C++ pattern. Or in Python, actually, if you go to Python, you'll see where they use self this, self that. Yeah, so something like this.
You're trying to do like object-oriented programming.
Yeah, but in C. So that's the idea here. So every data that belongs to this instance is what is this? This is a control type, right? It's sent to the control type, and then in telemetry we just call it and get everything at once.
Mhm.
Then here,
Okay.
then here we decide, okay, which particular one do we want to call? That's why if you do something like tell, then you'll see different types, and you can. Okay, I have. Yeah, so if we go to controller, then we can just get data for each one. Yeah, so this is what we do here, and what is the so for this one, I'm just using, you can always change it depending on what you want to do, but for now it's just 10. So, and it also has the same priority or higher, okay, a little bit. It has one priority higher than the status monitor. Yeah, so that means it can preempt the status monitor. For now, it's just monitor is just an LED blinking on, yeah. So that's why I made it a little bit higher. And then the controller has the highest priority, which is 3. You can use higher if you want, but yeah, 3 is higher than what we have for the others. Okay. Okay, so I think that was necessary so that we can understand what is going on here. So okay, we still have some time, 18 minutes. All right, so let's see what we can do here before we. So in this, when we launch the control, right, and the control tags, yeah, we are assigning this function. This is the function that is being called. So it's a callback function that runs continuously. This control run. So when we create the tags, we come here. So this is the one that runs. That's why we have this while loop here, and it runs continuously every time. So first thing it does is to get updated channels from our radio. So what is the new set point that the pilot wants? It gets it every time. So the first thing it does is that. And then the next thing, of course, you guess is what is our sensor saying? So the next thing we ask for is our sensor data. And then after that, we can now go into the control proper. Yeah. So we go to the control, and then we have this, right? Okay. So we have this state machine going, and here we're just checking to see are we in a state to start the controller or not. So for the drone, provided it is on, it is always estimating the angle. So arming the drone or not does not affect the ECAF. ECAF is always on, so that's something good. So right now you can, if you the drone itself is not armed, but yeah, the EKF is going, the angle is, yeah. So this is pitch, yeah, and this is row.
Okay.
So that's one always on, because if you see we already have it here before even the controller starts. Okay, before we even talk about arming the controller, it's already on. Yeah. And also the set point from the pilot also. Okay, so in this first step, for safety, all the motors are turned off. Yeah, we don't want any mishaps. Yeah, all the motors are turned off, and then we check. Okay, if the switch A is less than the midpoint, then we can go into the next stage. Switch A of the transmitter. Okay, so this is a switch A. You can always change it to whichever one works for you, but this is what I use. So.
By the way, for me, my receiver did not work out of the box. I had to like manually configure the channels.
I think Jasper had that problem.
Yeah.
Yeah, so maybe like I could write up exactly. I remember the steps I did, but someone new person might definitely get one.
No, I totally agree.
Which one did you buy?
I bought I bought the what is it? Fly Sky FS1i6. FSI6.
Okay, you didn't buy the X. So
Oh, it is the X. FSI6X.
Okay, then it's exactly the same. So what was the issue actually?
Well, the issue was that the SWA was, let me try to remember. The SWA was automatically set to it was working with these knobs instead of the switch.
Oh,
I had to modify
Oh,
the
yeah.
channel.
okay.
Exactly. Yeah.
Well,
Yeah.
it probably is the same for me, but it's been a long time since I did this. I bought this like 5-6 years ago.
Yeah.
I'm sure I've forgotten the setup. It works, I just keep using it. Yeah, but yeah, it'd be nice to write it down. And
Yeah.
something I remembered is the binding. I know I've not thought about the binding. Binding the transmitter to the receiver. How did you guys do that?
Yeah.
And
So,
of course, I think you guys have this with X at the end. You're the rich guys. Mine doesn't have an extra letter, so
okay.
it's very basic. But I think I face the same issue as Hamza.
Yes.
It would need some little bit of notes because I ran it around, and yeah, maybe it
It
can
has 10 channels. So it has 10 channels. It can only have seven active. Well, automatically your code was using the first 5 of them worked. Like the throttle, the roll, the pitch, they were all working. It's just that I believe channel 5. I think you have SWA set to channel 5 right now.
Yeah.
If you go to your, you had to define for the channels.
Yeah, let me see. It should be in set pointed.
Yeah, so it's okay, yeah, so it's set to channel 5. The channel 5 for me, I had to let me double check. So you have to hold the OK button and then go to system, and then you go all the way down to aux switches, and you can see the different channels you're on.
I think this is better than commented.
Yeah, okay. I can document it. I have to try to remember exactly because it was like 2 nights ago, and I was like, it was late, and I was trying to figure it out. So
okay, so yeah, so that's channel A for arming the drone. And yeah, of course, when we have it in the other direction, we can now enable the controller. Okay. And before that, we initialize some set points and also initialize the PID. Okay.
Mhm.
Okay. So the next step we have here. So this is where we actually call the set points, and we call the PID controller, and we get the data returned. Okay. And here as well, we're also checking to see, okay, as at any point has the pilot turned off the switch, yeah. So that's to disable the controller. This would be very bad if your drone was already in the air, yeah. But okay. So then it will move to the state disabled, and then from disabled we go back to yeah, the safe start. Okay. So what else? Okay, so of course the data we get from here, we get from the controller a PWM value for the motors, which we set directly here. Okay, and all this data we can already assign to this variable. So that's it. And so with this, so this is the only data that a calling function can access from outside this file. Yeah, so just call this and you get everything you need. Yeah, so that's it. So shall we, maybe we go in step, let's go to the controller, maybe that's interesting. Let's see what we have here. So here we are initializing the PID. Yeah, of course, we're just setting everything zeros, and yeah, the integral values, the PID saturation values, putting them at 0. reset points or the zeros, or kind of make some definitions here, assign some constants, like for example this is like the maximum PID and all that. We assign it to our PID variables, okay? And then here, this is the PID proper, and we have just 8 minutes. We can't go through everything, but let's just get the main idea of the PID. Okay. So previously everything was in one, like in this function, but I just broke it down. Yeah, so this is like the proportional part, of course, the integral, the derivative part. Then, of course, when we have these three things, we can now combine them into, I don't know if you've done something with the PID. I'm sure Jasper has. Hamza, have you done something with the PID before?
I've done some research and I've learned a lot about it.
Okay.
So yeah.
Once we get these three parts of the PID, we can now combine them into a control input to the plant. And in this case, the drone is the plant. So this is the control input. And so, but before we don't just directly send this to the drone. We need to do set some limits, because for example, the PWM values have to be cut off at a particular point and things like this. The force we're trying to. So this is what we do here. We say, okay, we limit the correction, and this part of the code is for correcting something called integral windup. So the integral, it accumulates errors over time, right? And because if you have the drone on and you give a command, and for some reason the drone is not responding, maybe you hold down the drone or something, and it's not applying that correction, this error builds up. Yeah, because the integral wants to correct, and you're not allowing it to make the corrections, so it keeps building up this error. So in this case, you can have an integral build up or integral wind up. So we have to combat that with integral anti-wind up clamping. Yeah, so we have to clamp the integral so it doesn't go out of control. So that is what we have here. And then in this part, so once we have done all this and everything is fine, we can now safely give the control input to the plant, or the control input to the drone, to this motor mixer. So this motor mixer is what says, okay, which motor gets what and about what amount, right? So we have any confusion there?
No, it makes sense. Like isn't like in the physics of a drone, you can set the roll, pitch, and yaw independently of each other in the formula.
Yeah. So, and I think we definitely have to do this some other time to go through it properly. But yeah, that's basically.
And just out of curiosity, I saw the PID components where the function prototypes were not uniform. So I can see the proportional part has those arguments. The integral has none. The derivative has IMU. Any?
I went with the flow.
Okay.
I went with the flow. Nothing special here. I just okay. Yeah, maybe this looks nice here. But yeah.
Okay.
So it can definitely be better for sure.
Okay.
But this is very important. Like this was a very important part for this, because on a typical PID, here you make an actual derivative where you take the previous error and the current error, subtract it, and divide by the sample time. Yeah. But in this case, we are lucky because we already have that for free from the gyro rate, so we don't need to do that. If you get what I mean. So the angle itself, okay, the angle is in degrees, right? So normally you come here and say degree, this degree, previous degree plus the current degree divided by the time. But already we already have this from the Gyro, so we just use it directly, and we don't have to make any divisions. I don't know if you have done a derivative before. It's very, very ugly. The signal is never clean. It's always like very noisy, and you have to then apply a low pass filter. And then apply low pass filter, then you get a bit of lag. Okay, how fast should it be? How, the cutoff, depending on the cutoff you put, then you have it lagging or not. So for example, you move your drone, and then maybe some milliseconds later, then it moves. But for this case, we don't have that problem. Every filtering that we did was already done in the IMU. So we just set the IMU. So anything we did there is fine. We don't need to add an extra low pass filter at this point. So that was really, really, really helpful.
Okay, nice.
Okay,
yeah, because
maybe we'll call it a day, because any moment from now we'll be cut off in 2 minutes.
So maybe we cut off quickly. So I don't know. My point is, for newbies, the architecture would help if you could have that diagram again, but also show the flow of maybe an example reading through the modules that you show in your architecture. So how let's say the IMU.C relates with the sensor.C to the EKF.C and filter.C, this signal path. So that when they use that and go to code,
there's a lot to do, right?
I don't know. Personally, from a computer science background, I feel like the architecture diagram is like enough to understand a lot. Maybe like put a little bit of header comments in the file describing what it is. But I think that's enough.
It's kind of simplified, because from this you don't know there's there are 3 tags here, and then there is a RTOS and something here. Yeah. Okay. I think we're
Okay.
I think we are out of time. Okay, but for some reason we're still here.
I mean, for our place we use UML, so I don't know how, because this is just a diagram of blocks, but UML would show you the core structures, for example.
Okay.
So you would see how the core structure is, even in the task context or whatever. And then some people would even break it further into a timing diagram as well, but that would be too complex. But just a core structure somehow.
I have a quick question. Is this the website that you guys use to download that viewer?
Okay. I think it's Parallel or something like this. Parallel F.
I found this website and I downloaded it. I just hope it's not like malware or something.
No, that's the right one.
Do you know why I was like kind of freaking out in the meeting, because I downloaded this software, right? And I had to download a Java JDK. So I installed it, and then I tried to run it, and then it started like there was an error log saying that like opening webcam or something.
Yeah, that's crazy.
I don't think it's a real error. It's just because I was running it on Apple Silicon, and it's actually x86 or x64. And in Mac, the webcam is a USB-C or as a USB driver or something like that. So like it was trying to enumerate all the drivers. It's popped up webcam. I was like, what the heck?
Yeah, even on my Windows, it flagged it. The Windows Defender flagged it when I downloaded it.
Yeah.
But on Linux, works fine, huh? But Windows.
But also, Hamza, you can just write a quick Python serial.
Yeah, I think I'm gonna do that instead. I think I'm just gonna either find one online or just write my own.
All right, thank you guys for coming to this very first live section, or second, right?
All right.
I had one with Jasper already 2 weeks ago. But
okay,
it was fun,
good.
And let's do this again. Okay.
Hopefully more people come this time.
Yeah.
Sure.
Oh, yeah. So see you guys, and let's keep building. Ciao, ciao.
Okay.
All right.
See you.
Yeah.
Bye.
Cheers. Thanks.
Bye.
Bye.